I start today part 2 of the chapter Plane Figures. The content of this video is area and perimeter of different types of quadrilaterals and some real life problems based on combination of rectangles and triangles. Let's start. Now, before we continue, let's discuss about area and perimeter of quadrilaterals. Case 1. If in a quadrilateral, one diagonal is given and the perpendicular drawn on the diagonal from both the opposite vertices are given. Let's understand through this diagram drawn. Here ABCD is a quadrilateral where the diagonal AC is given, and for the diagonal AC the opposite vertices of the quadrilateral are B and D. And if the perpendicular drawn from B to AC, that is BP, and the perpendicular drawn from the point D to AC, that is DQ, if they are given, then easily we can calculate the area of quadrilateral ABCD by taking two triangles ABC and ADC, where for both the triangles base and height are given. And for the triangle ABC, base is AC and height is BP, and for the triangle ADC, base is again AC and height is DQ. The area of the quadrilateral ABCD is half multiplied by AC multiplied by the sum of BP and DQ. Case 2. When the quadrilateral is a rectangle, its all the four angles are 90, opposite sides are equal. So perimeter is 2 multiplied by sum of length and breadth, and area is length multiplied by breadth. Case 3. When quadrilateral is a square. In square, as we know, all the four sides are equal. All the four vertices angles are 90 degree. Hence, perimeter of a square is 4 times its side. Area of the square is its side whole square, and diagonal is root 2 multiplied by side. Next case, when quadrilateral is a rhombus. In case of rhombus, its all the four sides are equal, but their angles are not 90. Since the diagonals are perpendicular bisector of one another, and finally area we obtain, that is half multiplied by product of its diagonals. Hence finally perimeter is 4 multiplied by its side, and area is half multiplied by product of its both the diagonals. Next case, when quadrilateral is a trapezium, where both the parallel sides are given and the distance between the parallel side is given, then in that case area is half multiplied by distance between the parallel sides multiplied by sum of the parallel sides. So here if A and B are the parallel sides and h is the distance between the parallel sides, then area of the trapezium is half multiplied by h multiplied by a plus b. And to calculate perimeter, we need to find out AB and DC, and that can be obtained using Pythagoras theorem. Next question. Question number 3. How many tiles, each of area 400 cm square, will be needed to pave a footpath which is 2 meter wide and surrounds a grass plot 25 meter long and 13 meter wide? Observe this diagram. Here we find that a grass rectangular plot of 25-meter long and 13-meter wide is shown, and this rectangular grass plot is surrounded by a path of 2 meters. So first part of the solution is to find out the area of the path, and next part the number of tiles required. Area of the footpath is area of the bigger rectangle, that is ABCD, minus the area of the grass plot. The area of ABCD is 25 plus 4 multiplied by 13 plus 4, and area of grass plot is 25 multiplied by 13. The result of area of the footpath after calculation obtained is 168 meters square. The next part is the number of tiles required to pave the footpath. Total area of the footpath divided by area of a tile, and the area of the footpath calculated is 168 meters square, and the area of one tile is given 400 centimeters square. The expression is the area of the footpath, that is 168 multiplied by 100 multiplied by 100 centimeters square, divided by area of one tile, that is 400 centimeters square, and finally the result obtained is 4200. Hence number of tiles required to pave the footpath is 4200. Next question, question number 4. The diagram given below shows two crossed paths drawn inside a rectangular field 80 meter long and 45 meter wide. The width of the two paths are 8 meter and 15 meter respectively, as shown in the diagram. Find the area of the path. Since both the paths are rectangular, hence their area is length multiplied by breadth. For the longer and thinner path, the length is 80 meter and breadth is 8 meter. Hence, its area is 80 multiplied by 8. For the shorter and wider path, the length is 45 meter and breadth is 15 meter. Hence, the area is 45 multiplied by 15. Now, the problem is the area of intersection of these two paths, that is shown here in the diagram using red rectangular box, is repeated here. It means this particular area has been added 2 times. So once let's subtract that from the total area, and the dimension of this rectangular repeated area is 15 meter and 8 meter. Hence 15 into 8, which is being taken twice here, so once it should be subtracted, and now that comes in the expression. Finally, the total area of the path is 80 multiplied by 8 plus 45 multiplied by 15 minus 15 multiplied by 8, and the result is 1195 meters square. Let's understand the alternate way easier than the first one. Let's assume that these paths are being shifted to any end of the rectangular field. It means if the shorter and wider path shifts towards the left end and the longer and thinner path shifts towards up end, then the area of the footpath will simply be the area of the field minus the area of field without path. Then the area of the footpath is the total area minus area of the remaining field without footpath. Here the total area is 80 multiplied by 45 and the area of remaining rectangular field leaving the footpaths is 80 minus 15 multiplied by 45 minus 8. And after simplifying the expression, the result finally obtained is 1195 meters square. I hope you all understand this alternate way. Next question, question number 5. The question says, two adjacent sides of a parallelogram are 24 centimeter and 18 centimeter. If the distance between the longer sides is 12 centimeter, find the distance between the shorter sides. Since this question is very simple, diagram is not needed and easily you all can understand. Let's proceed. I assume here the distance between longer sides, that is h1 centimeter, and distance between shorter sides h2 centimeter. In the question it's mentioned that the distance between the longer sides is 12 centimeter. It means distance between the two parallel sides, that is 24 centimeter, is 12 centimeter. It means h1 is given, that is 12 centimeter, and h2 we have to find out, that is the distance between shorter sides. And by formula we know that area of a parallelogram is equal to one of the two parallel sides multiplied by the distance between them. So here area of the parallelogram is 24 multiplied by h1 or 18 multiplied by h2. Since both the expressions represent area of the parallelogram, hence 24 multiplied by h1 is equal to 18 multiplied by h2, and finally h2 is calculated, that is 24 multiplied by 12 whole divided by 18, and finally the value of h2 obtained is 16 centimeter. Hence distance between shorter sides is equal to 16 centimeter. Next question, question number 6. The question says, the rate of a 1.2 meter wide carpet is rupees 40 per meter. Find the cost of covering a hall 45 meter long and 32 meter wide with this carpet. Also find the length of the carpet if the width of the carpet is 80 centimeter. Solution is very simple. As we know, the area of the hall is equal to the area of the carpet required, and since the width of the carpet is given, hence length of the carpet required is area of the carpet divided by width of the carpet, means area of the hall divided by width of the carpet. Solution is very simple. As we know, area of the hall is equal to the area of the carpet required. As we know, area of the hall is equal to the area of the carpet required. As the width of the carpet is given, hence the length of the carpet required can be written as area of the hall divided by width of the carpet. Values are put in the expression and calculated, and finally the length of the carpet required comes 1200 meter. Now the cost of the carpet required at the rate rupees 40 per meter is rupees 40 multiplied by 1200, and the result obtained is 48,000. So cost of the carpet required is rupees 48,000. Next question, Question number 7. Study the following diagram and find the area of the field. Given AF equal to 50 meter, FG equal to 40 meter, GH equal to 15 meter, HD equal to 25 meter, BF equal to 50 meter, EG equal to 60 meter, and CH equal to 25 meter. Observe the diagram given. It is a combination of some triangles and a trapezium, where for all the triangles, base and height are known, and for the trapezium, the value of two parallel lines and the distance between them also is given. So directly formula we can use and find out the area one by one and add them to get the area of this polynomial A, B, C, D, E. First of all, the area of triangle AED, where the base AD is given 130 meter and the height EG is given 60 meter. Hence, area of the triangle AED equal to half into 130 into 60, and the expression results in 3900 meters square. Area of triangle AED equal to 3900 meters square. Next triangle ABF, where the base and height AF and FB are given 50 meter each. Hence, area of the triangle ABF is equal to half multiplied by 50 multiplied by 50, and the expression results in 1250 meters square. Therefore, area of the triangle ABF is equal to 1250 meters square. Next is area of the triangle CHD, in which base and height CH and HD are given 25 meter each. Therefore, the area of the triangle CHD is equal to half multiplied by 25 multiplied by 25, and the expression results in 312.5 meter square. Therefore, area of the triangle CHD equal to 312 meter square. Next is the area of trapezium BFCH, where the two parallel sides HC and FB are given 25 meter and 50 meter, and distance between them is FH, and that is 55 meter. Next is area of the trapezium BFHC, where the two parallel sides HC and FB are given 25 meter and 50 meter respectively, and distance between these two parallel lines, that is FH, is equal to 55 meter. Therefore, area of the trapezium BFHC using formula half multiplied by sum of parallel sides multiplied by distance between the parallel sides is half multiplied by 50 plus 25 multiplied by 55, and the expression results in 2062.5 meters square. Therefore, area of the trapezium BFHC is equal to 2062.5 meters square. Finally, area of the complete field is area of the triangle AED, that is 3900 meters square, is area of the triangle AED, that is 3900 meters square. Here the value I have written in two parts, 2700 plus 1200. These two areas are the area of triangle AEG plus area of the triangle EGD, and altogether it is the area of triangle AED plus the area of triangle ABF, that is 1250, plus the area of triangle CHD, that is 312.5 meters square, plus the area of trapezium BFHC, that is 2062.5 meters square. Finally, the sum of all these areas is the area of the field, and the result is 7525 meters square. Hence, the area of the polynomial ABCDE is equal to 7525 meters square. This one is your first homework on the chapter Plane Figures. This homework is based on triangles and quadrilaterals. In question number H1, the diagram contains a right-angled triangle ABC and an equilateral triangle BDC. The next question number H2, is based on two rectangles. First rectangle is the floor of a room and next rectangle is a tile. The next question, number H3, this also is a combination of right angled triangle ABC and an equilateral triangle BCD, which looks like question number 1. But the difference here is the triangle BCD, you have to prove first that it is an equilateral triangle. Complete your homework. Here we complete part 2 on the chapter Plane Figures. In this chapter, we discussed about different type of quadrilaterals with their area and perimeter and the combination of quadrilaterals and triangles. I hope you understand the class very well and satisfied. For any doubt, you can contact any of us. Thank you.